Right, this video is going to be about basic steps of the scientific method. Now, most people who are taking introductory psychology have had this in some form at some point. This is probably not the first time you're hearing it. Another issue with learning about the scientific method is depending on which textbook you use, you might have like one more or one less step than the textbook that I'm using for this class. So, just keep it in mind, and especially if you're taking another class at the same time as this one that also goes over the steps in the scientific method, it may not say things exactly the same way with exactly the same terminology, but the general ideas should be the same. So with the scientific method, this is a way of examining our ideas about the world. You can examine common sense beliefs, or you can get your ideas from previous research, but the idea is you want to gather evidence that can give you insight into the truthfulness of things that you think, are true, things that, explanations you have for, in the case of psychology, behavior and mental processes. So with the scientific method, the first step, and this one often does vary, but the first step is to identify some problem. Basically, something you're curious about. Some people will word this as asking a question. It could be a question like, hey, what makes it likely that people are attracted to each other? That's a nice general question. That's a problem. That's something you want to understand better. That could be a good first step. Now, you're not done, all right, when you do that, but this can move you towards doing some science, doing some research. Now, once you figure out what you're interested in, you also have to learn more about it. And so you have to do background research. Background research, depending on what level you're at, this can involve different specific activities. But typically, when you're at the collegiate level, you should be using your university library resources, databases that are available through the university library to look up trustworthy sources. What do we generally consider trustworthy in scientific fields? We generally put our highest trust in journal articles. All right, and these are not the same thing as magazine articles or newspaper articles, but journal articles that are published in these special types of publications that we call scholarly or peer-reviewed publications. The peer review part means that not anybody can publish there. It's not the sort of publication where if you have money, you can publish there, or if you have the prestige. The idea is that peers review your work. Who are the peers here? The peers would be other scientists. You submit a project. Other scientists who should be experts or very experienced in a field, they should look over your work and verify that you did the work correctly, that you interpreted your results correctly, that it's important enough to publish in the journal. All right, so you want that type of evidence ultimately. When you're in high school or maybe in other classes, it might be acceptable to just do a Google search, get ideas from Wikipedia and things like that. But in scientific fields, it's really important that you get peer-reviewed research. It's just a higher level of trustworthiness. And psychology majors, when you take Psych 220 on my campus, Principles of Research Design, you get more information about how to do that. All right, so why do this background research? You have to know what's already been done. You have to know what's already been examined, what we know so far about this particular topic or research question or problem. And then a very important step is based on what you've observed in the world personally and what you find in your background research, you then get to formulate a hypothesis. I'm hoping you've learned this word before. You may need a refresher of what this is. People define hypotheses in different ways, but you may have heard that a hypothesis is an educated guess, that it's a testable prediction. Those are both decent ways to describe a hypothesis, but a hypothesis is an explanation for your observations. And it's also a prediction about what you would expect to find in a study of your specific research question. So a hypothesis can take the form of people who have more similarities in music and movie interests are more likely to agree to a date with each other. Right? That's a hypothesis. It is testable. You can gather data. And what do I mean by data? You can observe people. You can make various measurements, various observations, and you can gather evidence that either refutes or supports that particular hypothesis. Now, hypotheses must be testable. You're not really doing science if you propose a non-testable hypothesis. What would make something not testable? Well, if you have poorly defined terms, that can make testing difficult. If you have vague terms, or sometimes you might have a component of your hypothesis that is not inherently observable. Like what if you might have a hypothesis that people are drawn together because of ghost-like forces, because of invisible threads that we can't see that make them drawn to each other. Interesting idea. Can we test it? No. These are things that are invisible, essentially. You can't test that. That's not actually a hypothesis. A hypothesis does have to be testable. Now, the next step, test your hypothesis. You have to do your study, conduct your experiment or other study, and see what the actual measurements, the actual observations say. Do they support your hypothesis or do they refute your hypothesis? Notice I didn't say prove the hypothesis. That's not how we conduct science. Prove makes it sound like you're done. And that's not how we do things in science. You can find evidence for a hypothesis. You can find evidence that's supportive of your hypothesis, but it does not prove your hypothesis. It is just one piece of the puzzle. Because after you do the next step, you analyze your results, and this is why psychology majors have to take statistics. The Psych 221 and 222 here on my campus, the psychological statistics classes, the reason you have to take those is part of research is analyzing your results with statistical methods. You have to see what do the numbers actually say. Once you get your results, an important step is replication. Replication is where you do your study again, or someone else does your study again. Sometimes the same study, sometimes a very similar study with slight changes. But remember the word consensus when we talked about false consensus? The way to know if you have a consensus, if you have agreement and consistency in your findings, is to replicate. Replication is a very important part of science. So we never prove ourselves right. We support our hypotheses. We gather more and more evidence for our hypothesis until we have consensus for the status of that hypothesis. That's how we do things in science. And another important step, you got to report your results. Hopefully, ideally, you'd be able to publish your results in one of those peer-reviewed journals. That may not be possible because the best stuff gets published in those journals, but you may be able to present at a research conference. And there are various avenues for reporting your results, but your results aren't helpful to the field of science unless other people can know what you found, and then we can see if there's a consensus. So those are all important steps in the scientific method. All right. Psychology majors will learn more about that in future classes. Non-psychology majors, the majority of people taking introductory psychology. Hopefully this at least gives you the appreciation that we don't just make things up on the spot. As psychologists, we do have to go through a lot of steps to say something is true or supported. Oops, I missed, there we go.